Have you ever wondered why the sky is blue during the day and transforms into fiery hues at sunset? This phenomenon is due to the way sunlight interacts with the Earth's atmosphere. We'll explore the science behind this beautiful daily spectacle. Sunlight appears white to our eyes, but it actually contains all the colors of the rainbow, each with its own wavelength. When white light passes through a prism, it separates into its component colors, creating a spectrum. This visible spectrum ranges from violet light with the shortest wavelengths to red light with the longest wavelengths. Visible light is just a small portion of the much larger electromagnetic spectrum. Within the visible light region, blue light has shorter wavelengths, while red light has longer wavelengths. This fundamental difference in wavelength properties is crucial for understanding why the sky appears blue during the day. Rayleigh scattering is the phenomenon that explains why the sky appears blue during the day. It occurs when sunlight enters Earth's atmosphere and interacts with the tiny air molecules that make up our air. The primary components of our atmosphere are nitrogen and oxygen molecules. These molecules are much smaller than the wavelengths of visible light, which makes Rayleigh scattering particularly effective. When sunlight strikes these air molecules, the light waves are scattered in all directions. However, shorter wavelengths of light, like blue and violet, are scattered much more effectively than longer wavelengths, such as red and orange. This scattered blue light reaches our eyes from all directions in the sky, making the sky appear blue during the day. The effect is most pronounced because air molecules are much smaller than the wavelengths of light they scatter. In summary, Rayleigh scattering occurs when sunlight interacts with atmospheric molecules, scattering shorter blue wavelengths more than longer red wavelengths. This is why we see a beautiful blue sky on clear days, a daily reminder of the physics of light in our atmosphere. Earth's atmosphere contains various particles and molecules that become less dense as we move higher above the surface. This changing density plays a crucial role in how sunlight interacts with our air. Near the ground, the air is thick with nitrogen, oxygen, and other molecules. As altitude increases, the air thins out with fewer particles per volume. This gradient of density affects how light travels through the atmosphere. When sunlight enters our atmosphere, it encounters these particles. The denser air near Earth's surface causes more interactions, while the thinner upper atmosphere allows light to travel more freely. This is where Rayleigh scattering becomes most effective. The atmospheric density enables blue light wavelengths to scatter much more efficiently than longer wavelengths like red or orange. In denser air, blue photons bounce off molecules more frequently, spreading in all directions and making the sky appear blue. This relationship between atmospheric density and light scattering explains why our sky appears blue during the day. The denser air near the horizon enhances this effect, while the changing density throughout the atmosphere creates the beautiful variations we see in sunset colors. As the sun approaches the horizon at sunset, its angle relative to Earth changes dramatically. Let's see how this affects the path of sunlight through our atmosphere. At noon, when the sun is directly overhead, sunlight strikes the atmosphere at a steep angle. The rays travel through a relatively thin layer of air before reaching the ground. As the day progresses, the sun moves lower in the sky. By sunset, it sits just above the horizon. At sunset, sunlight hits the atmosphere at a much shallower angle. The rays must travel through a significantly greater thickness of air, sometimes up to 40 times more than at noon. This extended journey through our atmosphere is what creates the dramatic colors we see. As the sun dips lower toward the horizon, its light must travel through a much thicker layer of atmosphere to reach our eyes. This extended journey through more air molecules makes Rayleigh scattering far more effective. The increased distance scatters away most of the shorter wavelength blue light. These blue photons are deflected in all directions by the air molecules, never reaching our line of sight. Meanwhile, the longer wavelengths like red and orange are scattered much less effectively. These colors pass through the atmosphere relatively undisturbed, allowing them to reach our eyes and paint the sunset sky. Other colors like yellow also make it through, though in smaller amounts, contributing to the rich palette of sunset hues we observe. This selective scattering explains why sunsets are dominated by warm red and orange tones, while the cooler blue light that dominates daytime skies is filtered out during this longer atmospheric journey. Various factors can influence the colors we see during sunsets. Pollution, dust, and other particles suspended in the atmosphere play a significant role in how light scatters and creates those beautiful displays. In clean air with fewer particles, light scattering follows the usual Rayleigh pattern, producing typical sunset colors ranging from orange to deep red. However, when the air contains more pollution or dust particles, these larger particles scatter light differently, often enhancing the longer wavelengths like red and orange. This can create more dramatic and vibrant sunset displays. As we've explored, the colors of our sky are explained by Rayleigh scattering. This phenomenon causes shorter blue wavelengths to scatter more effectively than longer red wavelengths through our atmosphere. During sunset, sunlight travels through a thicker layer of atmosphere, giving red and orange wavelengths the chance to dominate as blue light gets scattered away from our line of sight. Every day, this light show reminds us of the scientific principles at work in our atmosphere. The next time you look at the sky, take a moment to appreciate the physics behind its colors. Let this inspire you to observe, question, and wonder about the world around you. Science helps us understand the beauty we see every day.